final open discussions and closing. So you can stop me anytime if you want to talk about any issues. So you can talk about anything about it. Okay, so I will start with thanking people. So let's thank all the participants. And let's thank all the audience, including attendees. And let's thank Ms. Kim sitting on the back. I mean, maybe we should also thank a bus driver yesterday. Okay, thank you very much for your participations. And let's spend a little bit of time discussing the meaning of NHISS and probably including the future perspectives. And but I first need to give you a really hard issue. So we first have to resolve this. Which one is your favorite? This will determine our future. Okay, so this is a joke. All right. Oh, but it's not. I'm serious, by the way. It's not a really. So why NHISS? Again, the Professor Sherrill said quite long times ago. Maybe it would be nice to have some tools and components so that one can easily build the software out of it. So you do not need to spend a lot of time in creating everything from scratch, right? So, well, we actually try something. Actually, I tried something. I cannot ask students to do it because they don't like it. So, in this is actually it's still active, so you can go check it. But basically, I modularized very simple quantum calculation into pieces, right? Like reading parts, and then basis selection, and initial guess, and some one electron integrals. Oh, here, initial gas is here, and some one electron and two electron energy and things like that. So, once you, I mean, there are many different ways of making modules. Okay, this is just one example, and why we are doing this, by the way. Then, if somebody wants to develop new theory, and then he wants to put that into a package, like a big package, then it's not that easy, right? You have to learn the package, and you have to talk to those guys for permissions, for example, everything. But if you have some kind of this kind of modules, then you don't have to do it. You just, for example, you have a lot better initial gas, then you can simply replace this, remove this, and then plug in yours, right? So that was kind of motivation. Let me show you how you do it. Okay, how? So on your left-hand side, there is a list of menus, and you could we actually created many, and drag and drop, and you choose another one. I was confused which one to choose. Okay, then you have you can connect like that. You can connect that if you have the same data type. If you don't, you cannot connect. Okay, basically, as long as you have the same data type, inputs and outputs, then you can connect it. Okay, then you created a workflow, and you go to you can do the calculation right away. And I was confused which one to choose again, so it takes some time. So the first thing you have to do, and you have to type the name of the calculation. So then you have two red dots there, which means that it requires initial input data, right? So you click on the one of the button, it pops up the molecular editor, you create it, or you can just read it from files. And another red dot is kind of a selection of your types of the options, for example. And then I don't know whether Hartree Fock or DFT. Oh yeah, I'll choose DFT. Okay. All you have to do is submit, and it will submit to the cloud. So you don't need to know where it is running, and it is running. And basically, what is very simple example. The first module generates games info file. The second module is just the games itself. Okay. I did not know that generating games input takes that much a long time. But anyway, it does. Yeah, actually. You just and then run it automatically activates the games and will generate log files, and then after that you can do the post processing, things like that. Okay. This is a very nice tool and you can do it, but maybe this is good for the users, but not really useful for the developers, right? From the developer's point of view, we need a little bit more easier way of creating things like this, right? So then we go back and thought about what would be necessary to make things to be more usable. Well, we already have a lot of things. In fact, these days, unlike the old days, we have a lot of IT technology, right? So we have a lot of, you guys put a lot of beautiful open source, your open source software on the GitHub, a lot of them. But then you would you wish people download it and use it, right? But then it's not that easy, because if you just provide open source, then people have to download and compile, and there are some troubles, and then maybe there are some bugs, and there are many things that needs to be taken care of. So maybe, but we could try a little bit one more step for increasing their usability. So one of the way is it could be done in the form of a library with a standardized interface. So maybe we could think about some sort of a standardized interface of a library. So library from you and library from other people. So imagine something like a Python libraries. So this is the pseudocode of collaboration. Okay. It's a Python, okay? So we import John, John is missing. We import Miguel, and can we talk within the Python? I think it's possible, something like this. Well, it doesn't have to be Python environment, but I just choose Python because everybody uses Python. You could have some interface to Julia or any other languages. So instead of providing source code is wonderful, okay? So you open everything, right? But as a user's point of view, maybe if we can do one more step, one more service to them, like the creating libraries, then they could easily import it, right? So you can put your library into the repositories and everybody can download it and everybody can use instantly, right? And also Python might be the good environment, so it is less dependent on operating system. However, Python version dependency is also trouble, right? So there are other issues, but so if that is the problem, then we can even think about Docker image, right? We can have some sort of a particular operating system, a particular Python versions, and we can make everything in a one package as an image, right? Then people can just download the Docker image and they just use it right away, right? Without any compiling, things like that, right? So this is so another big kind of philosophy we had is the decentralization. Like Bitcoin, right? So I mean, traditionally, we all know that we have to make a package, big package. I'm not saying that that is bad. I mean, that we still have to have a big package of quantum chemistry software, right? But it'll be nice to have some alternatives to that. So like libraries approach. It could be library, but it could be others. Okay, I'm just telling you that the library is one of the possible packaging form, but it could be different. But if you do that, then we do not need a centralized control. In the case of package, somebody has to take full control and somebody has to make it work. Whenever we add a new functionality, you have to go through all the checkings, whether the new functionality breaks the original functionality or not, right? So this requires a lot of energy and efforts and time. However, if we decentralize these controls so that everybody just control their own libraries, which is much smaller and lighter than full package, and also it will certainly improve interoperability. And yeah, the second one was distributing maintenance overhead. I made a spelling mistake. Yeah, overhead. So so one person does not need to maintain the entire package, right? So that would somehow could be quite important. And also it could certainly expand the collaboration scope, because if you maintain package, then I mean, the nature of packages kind of tend to be closed, right? Although you want to be open, but it tends to be closed. But if you somehow decentralize this, then everybody helps with each other, everybody else, right? So, and also by providing, rather than source code, but providing some more usable forms of your software, then it could certainly reduce learning curves. And the last but not the least, it would be that I mean, everybody doing redundant codings. If you want to have a new functionality of someone else's package, then you have to recode it, right, from scratch. So that is really a lot of, we are wasting our efforts. So by like this kind of decentralization might hopefully reduce unnecessary efforts for the whole community, right? So then that would accelerate developments, right? We can focus more on the development than maintaining, right? So that's, I don't know whether this would be the ideal forum, but it's one of the possible forum that one can pursue. So maybe we have, this is the time that we have enough technology, IT technology, so that maybe we can rather easily achieve these goals. Unlike old days, in old days, simply not possible now, but we have a lot more. You know, if you say that you are doing a Python coding, but if you think about carefully, you are actually using Python libraries. Most of a great deal of the time that you're using, because that is one of the main reasons why we are using Python. And so why not just fully take the advantage of it, right? So we just create something like libraries for Python, then we can share instantly, right? And then those libraries can be connected to like this rather easily for the users. Okay, that is what I want to talk about it. Okay, so I want to say this, of course. Thanks very much again for your participations. And we wish you all the success in your work, and looking forward to meeting you again. And if you wish to say, it's okay. You want to please express your opinion. Okay. Oh, yeah, okay,
So,
yeah.
I don't know if that's what you want to do, but I think that's might be appealing to many people in the community who is doing any type of like both users and developers to some degree. So is there a way to push the button on the Edison and generate Python interface between those models and basically have the separate like Python script or something like that, which you can run anywhere? So for example, if you have some electronic structure code, some dynamic code, and some statistical theory code, and you drag and drop as you show, and then maybe push the button and that's generate the actual, because there must be some way to you transferring the data behind this graphical thing. So would it be possible to generate just a Python or something else? So I know
that
basically
yeah,
can be standalone effectively.
yeah, exactly. So that should be possible. And that should be one of the goals, because sometimes people doesn't want to or use the GUI, they just want to have a just script, right?
Yeah.
So yeah, in the under infrastructure, it has to be like that. That has to be just like the simple Python script that would connect all these things. And for the graphical user of graphical interface is for the simple user who doesn't know much about those. So what you're talking about is way much easier than just grab GUI. It has to be done that way on the bottom. Then we can easily transport that into so it's the other way of saying that, but yes.
But I think this alternative way will be sort of generating those interfaces, right? So will be very appealing to people who do development, right? So as you said, so that's great for the users. But if somebody do development, right? So that's always, I mean, you have students who, and you tell them like, well, take this code, and they both can do this thing. So all you have to do is to write like a script or something like transferring data or something like that. And then student goes away and he doesn't come back for 6 months, right? So so imagine you have something like this, where you effectively generate those interfaces with a push of the button, right? So that would be very valuable.
Okay. So that is a very good idea. So in the GUI, you connect all these things in the graphically, and then you push a button, it will generate Python script. Okay.
This is why we developed an open platform. So the reason is to go away and step away from this attached interface and create this framework for creating this workflow. So you can easily compile workflow and run it using this engine everywhere.
So depending on who you talk to, some students really wants to use GUI, and some students just hate it and just do the Python. But we could do both by combining this. So at the end, it should be the identical Python script, right? So.
And there are examples, by the way, of that. So I know if you, I got involved in all this quantum computing things, right? So in the last few years, so we sort of I guess on QoS side and quantum information science side would be this KISS, right? So I don't know if anybody heard about that.
I heard about it.
IBM developed tools, so you go online basically on a site, so you have this GUI, right? So where you do exactly what you show, you drag and drop like and connect the individual quantum gates basically, right? And that's how you write the program. And then, but it's also produced when you can do it graphically, but on the side Windows, it's also effectively the
code, right? Yeah.
In fact, there are two different, like one is basically Python, and one is actually higher level, what they call like use kit.
Okay, I see.
Like that, so which is kind of use Python library. So there are really 3 levels then. There are there are like some Python, and there are some intermediate basic.
Okay.
As well.
I see. Yeah.
And that's been quite successful.
I see.
I mean, of course, IBM has a lot of support. for that
I
type
see.
of, resources are very different there, right? So, but still, this is the sort of concept which I think reasonably proven by now. So it works.
So it's yeah.
Just comment. If you run Locus, you run in not one program, you run in quite many programs, so you have the same thing. You have the same problem, but you need to have some connections between them. And this one project, which a little bit on hold now, but I recommend you to look at this. It's called MolGUI.
MolGUI, okay.
So if you just look, but you will find this. It's quite big thing, which is doing pretty much the same as Edison, because you can choose some template for calculations you make. Well, it's provide you a network of models which you connect and you can edit them. And then you, of course, make indeed some check small thing which you can use. And then you can submit this calculation. So it's just recommended because it's two quite similar ideas, I think. And if you can use or reuse it, this LGPL code, you are really welcome.
So is it a self-hosted code or is based on some other?
Well, I didn't code this, I only designed this. So it's the code which is, how to say, self-containing everything. It contains molecular builder, it contains input generator, and some manager of problems, because when you running your calculations, you would like to have a project. Inside this project, you have all these calculations and stored in a specific way. Well, it's much more easy to look at this rather than to explain this. So just Google for MolGUI.
MolGUI, yeah.
And one thing which I dislike about this, it's a little bit of monstrous thing, because it's trying to do everything. And it's was written by a contract which Marcus gave to some Chinese university, university. So no one is supporting this now. So it's lying down. You can use it. So if you can reuse some ideas, you're really welcome.
Yeah, this is really trouble because there are very nice ideas, but then it started with really energetic mood, but then at the end, it's not well maintained somehow. So that's yeah. Go ahead.
So actually, I wanted to get Valera's comment also, because when we're talking about maintainability, well, I don't think you can just leave it to people. I think if you just leave it to the community to maintain it, it's not going to. You are going to need someone. I mean, and Valera actually said that in his talk. But the thing is, from my point of view, the thing that's making it difficult to maintain is what do you get out of it? So with my career, I just spent all my career programming stuff, but I got nothing back out of it. So, you know, in the end, all I am is computational chemistry support. I couldn't get a job because no one wanted just people to program things up. So, I mean, you've got all these people who've got all these wonderful ideas to sort of program up new stuff and try stuff. But if then you make it, I mean, it's just sort of like, seems to be just a one-way sort of like a lot of effort. There are lots of people happy to use your work, but people aren't going to maintain it because, I mean, maintaining is even less rewarding than actually programming.
Yeah. So one of the things that these days very active is Python library repository, right? We could create some sort of similar repository at least, and start exchanging those components so that people can reuse, and at least the repository will survive. And but somebody has to maintain that repository, and who's going to do it? Well, at least we can try for some years, and we can. I will try to find some fundings to do it, and if it's successful, I mean, it's if people finds it useful and people finds it very attractive, then they're gonna use it, and that would attract more people. So I think it's yeah. Go ahead.
So I got distracted by that comment from the original thing that I wanted to make, is that I can totally understand what you're saying from the point of view of the Gaussian model, if you think of it as being a community model. So the thing that was great for me about Gaussian was that I wanted to program up CAMB3-lib. And I didn't need to program up the integrals. I didn't need to program up the functionals. All that structure was there. So the reward was that, you know, we had this community. And what I was actually getting back was being able to use other people's codes. So actually, if you do have a community where everyone is sort of like submitting codes and then benefiting from it, then that will work. But then even with Gaussian, they went commercial because they knew that they wouldn't be able to keep going if they didn't have sort of money coming in, because no one's going to pay you just to maintain code. So I do believe that you need to have someone sort of that's willing to maintain it, but you're not going to get that maintainer just out of someone's goodwill.
Yeah.
Yeah, maybe in this connection from a more administrational point of view, I think what also would be needed some kind of a web page so that people could see what is available. Because if I say my student go there and pick something, then he would probably come back and would be confused. So there should be an updated version, what is available, what can we do, and maybe also a help forum. If you have a problem that people can easily go to a website and then that they can exchange. But of course, again, who would do it? Because this needs resources.
Sure, definitely. And also it has to be maintained very carefully. Otherwise, as you just said, it could be if website is trying to confuse people, then they would just stop, right? And so somebody has to do something. That's the point. And that is one of the reasons why we started this. And maybe I will try to find some fundings for supporting this at in a stable way. And one of the our initial goal is that as a Vladimir here sitting right behind you is trying to create a OQP, Open Quantum Platform. That's our name. Try to demonstrate and try to show you what you can achieve out of this, how we could exchange, how easily we could exchange our source code through this interface. And so maybe that is kind of is coming. So I think that we should first get a publications so that it has to be clearly defined and clearly written, and people can understand more clearly. After that, maybe we should also set up some sort of a web page very carefully. And so gradually, yeah.
So in a weird way, if you are chasing funding, because we're actually doing this with our winter school, and also when we talk to CCAM and people like that, if you're chasing funding, chase funding for the maintainers and the people who will do the boring job. So many people, you try and pay for high quality developers. But the thing is that if a developer is given a chance to do something they love, they will do it for free. But if you then give them the back structure of someone to do the really boring work, then you might find that that is where the money's worth spent.
Yeah. So I can also see that definitely we need a guy from IT, not just the quantum chemistry. Because this is kind of things that we don't want to do. Right? So definitely who is very interested in doing this from IT sector. So we should collaborate with them. And so that would be ideal organization. And we provide our domain knowledge, and they would make that available as user-friendly as possible. So I think that would be, so that is why I was asking you about the material studio was like things like that, because that just to get some idea for the GUI is good for the attracting users. But underneath, we also need a developer level, right? That's a different levels. So people who really wants to share their software through this infrastructure. And also we need a GUI level users who really wants to use this out of it, right? So, and so in order to satisfy and in order to keep these two levels, we need IT guys, and as well as we need quantum chemist, right? So kind of interesting combination, right? But that probably needs to be done. And that is one of the things that I'm trying to establish, but yeah. So if there will be NHISS 2023, then I'll be successful. But if not, okay. So this is so another comments, please. Okay, so I think that we talk about enough, and we kind of understand each other and what it needs to be done. And I think that I assume that you are expecting 2023, right? I assume that, all right? Okay, so okay, with that, let me say this again. Thanks very much again for your participations, and we wish you all the success in your work, and looking forward to meeting you again. Thank you very much.